Right. Welcome. Thank you for coming along to this session this afternoon on Extreme PowerShell Advanced Class. I'm kidding, don't worry. It would be an extremely short session if I was giving that, don't worry. So, we're going to look to this afternoon. Thank you again for coming. My name's Matt McSpirit. I'm a technical product manager based in Redmond, and I focus on Hyper-V and System Center and our competitive story against VMware. I'm a VCP. I'm a Microsoft Certified Professional as well, or MCITP, or whatever the new name is now for 2012. It seems to evolve so quickly. And it's my role at Microsoft to help our customers and our partners just understand how we can compare the technologies. This isn't about bashing. This is about respectful comparison to help you guys, whether you're a customer, whether you're a partner, just have a more informed decision about what our capabilities are, what our capabilities aren't, and how VMware may have some advantages in some places, and the same for Hyper-V. And this is a two-part series. So part one, we're focusing really on that hypervisor level comparison, looking at some of the key capabilities across a number of key areas. And then on Thursday in the afternoon, we're going to start to look at some of the more management-oriented comparisons around the private cloud story, automation, templating, all of that cool stuff that many of you may be learning about for the first time at TechEd this week. But before we dive into the comparison, it's important for us to understand just where we've been to get to this point at 2012 R2. So this comparison is going to help you compare what is going to also come in the future with 2012 R2, which isn't available today. A lot of it is focused on 2012, but where I've called out specifically in the deck 2012 R2 features, so you'll be able to know what's coming in the future and how that stacks up. But before we get to that, Hyper-V was first introduced in 2008 Windows Server. In fact, it was a beta right at the start of Windows Server's release in January, February of 2008. So it was an extra KB, you downloaded, you installed, and you got the beta version of what was codenamed Viridian at that time. And then in June of that year, there was an update release, and it was now bedded into the product. But later that year, we released a free edition called Hyper-V Server. How many people have heard of Hyper-V Server? Okay, around half. That's good. The audience usually is a lot less. It's usually this kind of hidden SKU that nobody knows about. And it's like, surprise. Yeah, Hyper-V Server is a free edition of Hyper-V. It's got all of the Hyper-V good stuff, all of the features, the capabilities, but it was completely free to download. But at this time, in 2008, it was based on the standard edition of Windows Server with Hyper-V, which meant it had no clustering for resiliency. It didn't have some of the scale that the enterprise and data center versions had. So it was a little bit more limited and a little bit more restricted. But it was good to get going, and it was essentially free. But then a year later, things ramped up considerably, and people started to take a lot of notice of Hyper-V. Hyper-V was part of the 2008 R2 release from a Windows Server perspective, and the free edition that shipped alongside it, Hyper-V Server, was now brought in line with the enterprise and the data center editions of full Windows Server. So you effectively got more capability included in that free edition as well. So we ramped up a number of new features: live migration for moving VMs around, cluster shared volumes for better utilization of your storage, processor compatibility for moving VMs around between hosts with slightly different processor configurations or steppings, perhaps. Not Intel to AMD compatibility. That would be magic. And it's not quite as granular as that offered in the vSphere vMotion compatibility. But it's there in Hyper-V, introduced in 2008 R2. There was a number of other tunings, performance improvements that gave Hyper-V in R2 a big boost. And then a year or so after that, Service Pack was introduced, which doesn't normally bring features unless it's XP, Service Pack 2. Keep digging, here we go. But in SP1 for 2008 R2, it introduced two new features specific to Hyper-V. The first was dynamic memory, which enabled you to increase your density, and we'll explore that more technically as we go forward and understand how it compares and contrasts with the equivalent technology on the vSphere side. But then we also introduced a technology very specific for VDI, because we had users and we had organizations looking to deploy VDI for their users, but they couldn't quite have the richest 3D experience that they were looking for in a virtual desktop. Because we were presenting, just like all the other vendors at the time doing VDI, we were presenting a pretty standard graphics card inside that guest. But Remote Effects enabled us to put physical graphics cards in our hosts and present that through to the guest operating systems in a more direct way. So I would have a much richer, more native graphical experience inside the guest for a smaller subset of my users. It was largely limited by the scalability and number of graphics cards you had in that host, of which you've only got so much space in a rack or a tower server, or even less space in a blade. But that brings us forward to last year, when 2012 was released. 2012 brought a phenomenal number of features across Windows Server as an operating system. But the standout feature, selfishly for me, was Hyper-V. It just came on so much. There was so much added in terms of flexibility, improved scale, resiliency. And we're going to see all of those kind of things today. But don't forget, Hyper-V is just one part of Windows Server. Windows Server as an investment isn't just about the virtualization layer. It's a fundamental platform for you to deliver improved applications, greater scaled applications, to run the latest and greatest applications, and take advantage of the latest and greatest hardware that our partners are delivering. It's got 1,000,001 ties to Windows 8 and Windows 8.1 going forward that really provide a much better together story for you if you're going to deploy them simultaneously. But what kind of things did it bring in? And things we'll learn about in this session. Scalability, hosts, clusters, VM scale, phenomenally scalable. When we look at storage, the biggest cost of any enterprise infrastructure is storage. And we're trying to bring to market now solutions that can help you reduce the cost, reduce that cost. Virtualization helps us reduce costs from a power consumption, helps us be more agile. But storage, we want to help you reduce that cost as well and give you more capability. Migration enhancements we'll explore, integrating with our storage and our network and our server partners, offloading more stuff to them because they do a great job of that. So we'll look at all of those kind of things today. And what are we going to focus on in terms of that comparison? 4 key areas. Scale. Can I run my massive virtual machines on this platform? Can I run my big clusters? Can I run any workload in my environment? The answer is yes, and we'll explore that. And how does that stack up with vSphere? I'm running vSphere 5.1, 5, 4.1, whatever it may be. I know what I'm capped at in terms of my scale. How does Hyper-V stack up? We'll explore. We'll look at some of the security stuff. There was a huge amount of investment put into Windows Server 2012 as the foundation for R2 as well, around making sure it's the most secure and multi-tenant favorable platform in terms of virtualization for now and the next couple of years, to enable you to consolidate your workloads, isolate them as necessary, and provide that enhanced security to meet any compliancy requirements. But we want to be agile and flexible. We want to shift workloads around, but not be tied to certain network locations or certain host configurations. We want to pick up VMs and throw them literally anywhere in our infrastructure. And that's what was delivered in 2012 and enhanced in R2, and we'll explore some of that as well. And finally, it's great that you can consolidate hundreds of virtual machines on individual hosts, but if somebody pulls the power out of that host, stuff is going to go wrong. VMs are going to go down. We need a highly available solution. We need resiliency built in. How does that stack up with VMware HA, with fault tolerance, with vSphere replication, with SRM? We'll touch on those kind of things as we go forward as well. So they're my 4 key areas that I want to focus on. And there's a huge amount. vSphere, as it's evolved from 4, 4.1, 5, massive product. And their portfolio in general, beyond vSphere, is now just growing and growing and growing. It's hard to keep up from our side, and we're watching and keeping a close eye. But for you guys as well, who are probably embracing their technology and have an investment already, it must be hard for you as well. So hopefully this deck and the following presentation on Thursday will help you have that reference point at least. So let's look at some of the scale. What did we introduce? What was the kind of figures in 2008 R2? So if you think about our hosts, our virtual machines, and our clusters, from a Hyper-V 2008 R2 perspective, it was pretty capable. Hosts with 64 logical procs. If you think about the most common deployments today, 2 sockets, maybe 6, maybe 8 cores with hyper-threading. What's that? We're looking 32 logical procs there, and Hyper-V supports 64 in 2008 R2. More than enough for most organizations. For those running 4 proc boxes with 8 cores, then you're starting to hit the upper limit of what Hyper-V could provide in terms of that host support. But physical memory was more than enough. Virtual procs per host, yeah, that was all fine. Where we started to encounter a couple of challenges, particularly when people had slightly bigger workloads, was around that virtual procs per VM. I need a workload to scale up. And it needs to go past the 4 virtual procs that Hyper-V could provide. So that in some ways, especially when compared with what vSphere was delivering at the time, which was around the vSphere 5 timeframe, and to an extent 5.1, which was released towards the end of last year, it was kind of a night and day comparison, to be fair. And VMware was doing a really good job of showcasing that, showing big scalability, big virtual machines. The Monster VM came out at one of the VM Worlds. But, we'll take your Monster VM, VMware, and we'll have a Monster VM as well, and I'll show you that in a minute. But other things around our cluster sizes. 16 physical nodes connected together, maximum of 1,000 VMs on there. More than enough for most organizations, but not enough for every organization. And as people scale out, as service providers start to increase their capacities and they start to run infrastructures for other people, their needs are growing beyond 16-node clusters. So we start to see where we've gone in Hyper-V 2012 and R2, and these numbers are just blown out the water. 320 logical procs. I need to find the person in Microsoft who has this server, because somebody has tested it, and I would like to remove it from their possession and have it in my office, because that is a monster server. 320 logical procs, 4 terabytes of RAM. It's a monster, it's expensive, but it's just showcasing how Hyper-V is going to support that next generation of large-scale platforms, both now and going forward into the future. When we think about memory and virtual procs per VM, going from 4 to 64, a huge scale increase. Introducing guest NUMA, so that physical hardware topology. If you've got loads of processors and lots of memory, the NUMA topology of the physical host is important for where we run workloads most optimally and make use of local memory local to a processor. That's important considerations in the physical world. But we've passed that topology now through to the virtual machines, which means if you're running NUMA-aware workloads inside the guest operating systems, workloads like SQL Server, workloads like IIS, the Windows Web Server in 2012, they are NUMA-aware. So putting them in a VM where you've got lots of virtual processors and lots of local memory, you want to make sure that the topology that's presented maps onto the physical topology nicely. And Hyper-V handles all of that for you. So big increases on the previous release across the board, including clusters, 16 up to 64. And we've already had customers saying, you know what? I've chosen Hyper-V over VMware in 2012 because of that. I need that 64-node cluster for my infrastructure. That's why I'm going with Hyper-V. And it's given them a big cost saving, but in addition, it's given them that scale. Now, how does this start to compare with what vSphere is doing? Well, if we start to look at the comparison, host, VM, cluster, and I've got 2 different comparisons for VMware. There's the vSphere hypervisor, which anybody can download. Anybody can pull it down from the web, you activate it, but it's not got some of the capabilities that you would get if you paid for vSphere. Things like clustering at the bottom there. They're not part of the free vSphere hypervisor. You have to go and buy vSphere for that. They are part of the free Hyper-V server. So all of that HA, that cluster goodness that we'll touch on later, you can take advantage of. When we think about the scale, yes, Hyper-V is double the number of logical procs, double the amount of physical memory. But in reality, is that going to affect a massive number of people? Probably not. The scale figures of vSphere and Hyper-V are both more than enough for most organizations. And I imagine the next release, whatever it may be of vSphere, it will jump again. It will jump again, no doubt. Interestingly enough, when vSphere 5.1 was released and they announced their cluster size of 4,000 VMs per cluster on 32, it was previously 3,000 up to a very close period of time before the release of 5.1. And then suddenly, when we announced the release candidate of Hyper-V in 2012, where ours was also 4,000, it quickly jumped to 4,000. But unfortunately, at RTM time for Windows Server 2012 Hyper-V, we'd already tested 8,000 and released that anyway, so it was a bit late at that point. So we'd effectively doubled those virtual machine capacity on that cluster. Big scale, big capacity, but yeah, double the number of nodes. But don't forget that you don't need 64 nodes to run 8,000 VMs, because we support 1,000 VMs per node. Have I seen anybody do it? No. Will I likely see anybody do it in the next couple of years? No. But it's a scale that we can go to if need be on that big hardware. The key ones I want to focus on, though, are those VM-level scale pieces. Because VMware and Microsoft with Hyper-V both support 64 virtual procs per VM. Great. Massive workload, SQL Server, an Oracle database on vSphere, for instance, whatever it may be. But it's only the Enterprise Plus edition of vSphere that supports 64. 32 in Enterprise, 8 in the rest. With Hyper-V, even the free edition, it's 64. So you can take advantage of that at a much lower price point and entry point with Hyper-V. And it's going to enable you to scale those big, big workloads up without that SKU-specific consideration you'll need to make. The same goes for memory. There's now no VRAM considerations on vSphere, which is good for vSphere customers who move into 5.1. You don't have to think about that VRAM measuring and average usage and all of that stuff, which is good from an industry perspective for you guys. From a Hyper-V perspective, there's never been that VRAM consideration. Okay, so whatever you specify in the guest, you're going to be able to take advantage, no extra charge. So that's a little bit around the comparison at scale. But what have we been doing around storage? As I said, storage is one of the most expensive parts of the infrastructure. How can we help to advance your storage usage from both a Hyper-V virtual machine perspective, but also the host perspective? How can we do clever things within Hyper-V to increase performance and help you get better use out of that SAN you've paid probably a lot of money for? Well, first things first, if you've got a fiber channel SAN, how many people have got fiber channel storage in the room? Yeah, exactly, a lot. And you're not just going to throw it away tomorrow because something else is on the horizon right away. You're going to want to make use of that fiber channel storage for as long as you can, for as long as it's relevant. So having now the virtual fiber channel in Hyper-V that allows me to effectively connect a guest directly to the fiber channel fabric, masking or zoning the appropriate storage directly to the VM's worldwide no names and port names instead of exposing to the host is a useful tool. It's a useful tool for me, and it's been in vSphere for a while. But now it's introduced in Hyper-V back in 2012 in September. So very, very useful to take advantage, particularly if you want to put practically direct performance through from the VM to the storage. And in addition, if you want to create guest clusters using your fiber channel SAN investment. And we'll touch a bit on guest clustering later on because it's becoming more and more important for workloads, certain workloads. If you're thinking of taking advantage of advanced format drives, those with 4K sectors, Hyper-V supports that natively. It's not supported in vSphere yet. Okay, so if you wanted to run your virtual disks, your VHDX files, we'll understand and align appropriately to that. Fully supported with 2012 Hyper-V. But here's the big one. When you think about consolidating big VMs, 64 virtual procs, a terabyte of RAM, are those VMs going to be generating some data? I would have thought so. And they may be generating a lot of data. Now, our virtual hard disk format that was introduced back in virtual server, even further, ages, our virtual hard disk format that's royalty-free effectively was capped at 2 terabytes. You think, well, that's quite a lot. It is, but for some big workloads, it's nowhere near enough. But with VHDX in 2012, that enables you not only to take advantage of the 4K disk format, the better alignment, better protection against corruption on power failure, but it also extends the capacity from 2 now to 64 terabytes. Can I convert my VHDX files for VHD to VHDX files? Yes, you can. Can I convert them back the other way? Yes, you can, assuming it's less than 2 terabytes. That's a consideration. The beauty of this is it means you don't have to use lots and lots and lots of virtual disks just to achieve capacity. You may want to use lots of virtual disks for separation for certain I/O reasons relating to a workload, but in this case, you've got the capacity to go, 64 terabytes is plenty. And don't forget, each Hyper-V VM can have around about 255, 256 disks attached, so you're looking at about 16 petabytes of storage per VM, which is stunningly big. I've not seen it yet, but that would be the max. But something that was new in 2012, and something actually, I was presenting a course to a number of vSphere admins a couple of months back, and we were talking about virtual disks. And they said, I'm going to have to stop you there. Can I resize the virtual disk while the VM is running? And I just kind of climbed under the table. No. And I said, no, in 2012, you can't. 2012 R2, we're introducing that online VHDX resize, which is great. It's flexible. It's useful for admins. However, it's not just about grow, which is where vSphere stops. So vSphere, I can grow a VMDK file while the VM is running. It's been in there for a couple of versions with vCenter. I can shrink as well with Hyper-V. So if I do want to do some clever stuff and reclaim some space. If the volume isn't being used inside the guest OS, I can shrink the volume at the OS level, and that free space then I could then trim off the end of the VHDX. So I can reclaim that if I want. So some clever stuff going on there. Just gives you flexibility. But that is new in R2. So that won't be available in 2012. It will be available in R2 before the end of the year. But what else? Well, I can boot from USB. This is a common one I get asked, actually, from the guys who are running ESXi. Can I put it on an SD card? No, I can't put Hyper-V on an SD card. Can I put it on a USB? Yes, you can. You work with your OEM to do that, and it's Hyper-V server only, because the Hyper-V team will support Hyper-V running from the USB stick inside your chassis. But all of the other Windows Server roles that I could enable on a Windows Server machine, they're not willing to support it on USB. So that's why it's Hyper-V server only. Okay? And it's smaller, reduced disk footprint, less services running. So it may be the choice that you make to deploy anyway. But it's headless, so I will have to manage it remotely. However, that boot from USB is kind of like, well, isn't that a single point of failure? Yes, you've removed spinning media from your machine, your chassis, but you've now just got one USB stick. There's no RAID or any protection on that USB stick. If that fails, what happens? Well, it goes down. Right. Okay, so we've not actually gained anything from that perspective, but it's something that can be done. If that's what you want to do, if you've got a specific requirement to do it, you're good to go. But this is where we start to integrate. Loads of you had your hands up before around fiber channel storage. If you make sure that your firmware is up to date on those SANs, then chances are you'll be able to hook in with Hyper-V into those SANs and benefit from ODX, offloaded data transfer, which is a Microsoft equivalent, if you will, for those of you using vSphere in your environment, of VAAI, the vSphere Array Integration. vSphere API for Array Integration. I thought we were bad with acronyms. But VAAI effectively offloads certain tasks, like a storage vMotion, for instance. What is a storage vMotion in VMware? Well, we're moving blocks, the VMDK, from perhaps one LUN on the SAN to another LUN. Okay, so the SAN knows where it's moving from, and to, yeah, let's offload that task to the SAN and not use any of our host resources. ODX is a very similar capability for Hyper-V. So offloading those tasks through a standards-based API that our storage vendors are plugging into. All of the top storage vendors are plugging in, so you'll be able to take advantage. But it may be that you need a firmware update to take advantage of that. So check with your storage vendor. And then we think about how we can start to lower the cost. And this was talked about in the keynote. If anybody came to the foundation session, we talked about it there as well. But storage spaces is an opportunity to change the way you create, deliver, and manage storage within an environment. Moving towards simpler, lower cost, less complex, shared JBOD-type disk infrastructure presented to Windows Server file servers, and the file servers do the clever stuff around the pooling of disks and then the slicing them into LUNs, or what we all term storage spaces. And if I want this LUN or storage space to be mirrored, I'll tick mirrored. Parity, I'll tick parity. Simple, just striped, I'll tick simple. I've got the flexibility there. I can turn on dedupe. I can enable all of these capabilities. I can thin provision. So I can utilize the same kind of features I'm getting from SANs, but I've effectively built one using Microsoft file servers and commodity hardware. And storage spaces is a foundation for that. And vSphere doesn't have anything similar to that. I know there's things being worked on, things like vVols that are coming down the line, maybe in the next release, maybe it'll be pushed further. It's different. There's an acquisition from Versto from VMware. They're subtly different. What Microsoft is doing is helping to reduce that requirement, if you see it right for your environment, on SAN, and start to embrace commodity hardware. So if we start to look at some of the comparison there, yeah, we all do virtual fiber channel, even the free edition of vSphere. Multipathing is important. If you're going to connect and you're going to pay a lot of money for a storage array, you're probably not going to connect it to your host with just one path, because that's a single point of failure. So you'll connect multiple paths. Okay, multipathing now. We turn that on in Windows Server. It's in by default. It's not on by default, so you turn it on. But multipathing in Windows Server is a framework. So I can turn it on and I will see one version of the truth. I will see one LUN instead of two if I've got multiple paths using that MPIO framework. But that framework also allows our partners, our storage partners, to import their DSM, their device-specific module, which means you can talk to your storage vendor, say, can I have your DSM, please? Yes, thank you. Install it on your hosts. And what you've got then is an optimized multipath configuration from what that storage vendor thought was best for that array. Now, With VMware, you can do that same thing, but not with the free vSphere hypervisor. And in fact, it's only in the Enterprise and Enterprise Plus editions. MPIO is in there, but the ability to use third-party optimizations is reserved for the higher SKUs. So something to be aware of. With Hyper-V, it has been and will be just a core part of the OS. We talked about native 4K disk support and the massive scalability on the virtual disk compared to vSphere. Is that a blocker to some organizations? No. Does it make things easier? Yes, having those bigger disks to reduce the number of disks I have to manage individually. Hyper-V in 2012 R2 introduces that online virtual disk resize, but up until now, including 2012, it's not there. So you would have to either take the VM offline or hot remove the disk, increase its size, and then add it back again. Probably safer to just shut the VM down and incur that downtime to perform that task. We touch on pass-through disks. Pass-through disks, or raw device maps, RDMs in the VMware world, a little bit different. We would present a pass-through disk from the SAN, from your fiber channel, your iSCSI SAN. The host would do nothing with it, and you would attach it directly to the guest. And the guest would utilize it exclusively for its own gain. And yes, you may see near-native performance, but our fixed-size virtual disks now are so close to native performance that the inflexibility of a pass-through disk, it just doesn't make it worthwhile. But if I did want to use pass-through disks, I can still live migrate VMs around that have got pass-through disks, which is a common question I get asked. You've got a pass-through disk presented from a host, presented from the SAN to a host. Can I move that VM around? Yes, you still can. Okay? And the final area, that boot from USB, yep, it's across the board. Tiered storage. It's something unique to Windows Server from a virtualization perspective. It's in storage arrays. Yes, you'll pay money for it. It's in Windows Server in the core. It's VMware doing different things in storage. For instance, VMware have got a VSA, a virtual storage appliance. And some people put these two on the same page. Is Spaces Microsoft's equivalent of VMware's VSA? And if you're not familiar, VMware's VSA is essentially a way of transforming local disk storage inside up to 3 hosts, presenting that storage through to vCenter with a vSphere storage appliance, converting those disks into effectively a set of shared storage that's mirrored across those 3 hosts in that little configuration. But it's maxed at 3 hosts. So it's not really designed for the enterprise, but it's very suitable for things like remote sites, branch offices, and so on, avoiding the need to pay for SAN in those type of environments. So something useful. But it's radically different from storage spaces. Okay, so if you do get comparisons, if you do look at them on paper and think, now you know they're not the same. They're trying to achieve different things. So we think about resources and memory. When it comes to memory management, this was the biggest piece of feedback from 2008 R2, pre-SP1. What does VMware do around memory management? What does Hyper-V do? Why does Hyper-V have no memory overcommit? Were the kind of questions we'd get. With VMware, they've got 4 techniques. There's memory overcommit, there's compression, there's swapping, and there's TPS, transparent page sharing. Memory overcommit in the VMware world is as close to dynamic memory, if you had to compare them apples to apples, as we can. They're the closest to. So memory overcommit on the VMware side, balloon driver inside that guest to inflate and push memory out when it's not being used. On the Hyper-V side, we'll give memory to a virtual machine, we'll remove it flexibly, we'll allow you now to tweak the memory while it's running. So if I need to increase the maximum memory that we can give to a virtual machine on the fly while it's running, we've got that flexibility. Similar to with VMware with the hot add capability. But Microsoft does not and will not have a solution that compares to TPS, transparent page sharing. At least not in 2012, and it's not in R2. TPS on the VMware side, transparent page sharing, is almost like a deduplication for memory, for VM memory. If you think about running 100 XP VMs on one host, a lot of them are going to be doing the same kind of thing. There's going to be a lot of memory that is the same. And if the blocks are not large page tables, and I'll touch on that in a minute, not large pages, then it's easier for vSphere and ESXi to look across all of those VMs, find the memory pages across all those VMs that match, and deduplicate them. But with large page tables, which is on most modern hardware to increase performance, and it's reflected in the guest performance as well, with large page tables, it's a lot harder to match large pages in memory. It requires more effort, which means vSphere and ESXi only does that deduplication when the host is under a lot of memory pressure. So when it's typically running on a day-to-day basis and not under memory pressure, it's not going to kick in. And it does require resource to actually do that checking of all of the matching pages. Because remember, they're a lot bigger now, these pages. We'll check, we'll break them down into 4K, and then we'll deduplicate them. So there's effort that needs to go into that on an already overcommitted host. Hyper-V doesn't provide that capability. We rely on dynamic memory and the use of large page tables and the integration with things like SLAT-enabled processors to drive high performance. We introduced resource metering in 2012, and it's been slightly enhanced in R2 to reflect the capturing and tracking of data around CPU, network, memory, disk, storage IOPS, the works for individual VMs across your hosts. With VMware, with vCenter, they do a really good job, and many of you who are using it internally will know a really good job of capturing a lot of metrics. And I think they still have an advantage in this area around capturing metrics about the VMs and presenting it in a readable format straight in vCenter. And that's before you pipe it into Chargeback Manager or some of the other components within the vSphere portfolio. So they're doing a good job around capturing those resources. I think Microsoft, as a first effort in 2012, is going to collect those metrics and pipe it up into something that's consumable through a SharePoint form or a self-made dashboard, but combine it with Ops Manager within System Center, and you've got a great way of collating that information and viewing it in a much more readable way. And Network QoS was introduced in 2012, which enables me to select a NIC and say, you know what, this NIC, this VM is getting too busy. I'll cap the NIC at 100 meg, 200 meg, 500 meg, whatever it may be. If it's perhaps I need to give a consistent level of service, maybe I'll put a minimum floor on that NIC. And that will give me at least an SLA to go to that application owner. But VMware have had that for a little while now with network I/O control. So enabling you to essentially cap and manage the network bandwidth associated with VMs. But VMware also, for a while, have had storage I/O control, which with Microsoft is going to be introduced in 2008 R2. And storage QoS is going to operate on a virtual disk to virtual disk level and help me to put a cap on noisy virtual machines to prevent them from consuming all of the storage IOPS in that environment. So when we start to look at those, VMware have had some of these capabilities for a couple of releases now, from late 4.1 to 5 predominantly, and enhanced in 5.1. So Windows Server 2012 really got Microsoft on the board in terms of that SLA-based QoS for those network-based workloads. And in 2012 R2, it will go one step further and start to enhance around storage QoS. Okay? And you'll have all the slides as well, don't worry. So if you don't quite catch the photo, you can have them afterwards as well. There won't be any that are removed, don't worry. So, security and multi-tenancy. So that was a little bit about performance and stuff. And I know some of you will be dying to say, well, show me a performance comparison. I would love to show you a performance comparison, but I can't. If I want to publish a storage comparison, of which we're confident we would do a very, very good job of demonstrating our performance versus vSphere, we'd have to send the results to VMware, and if Microsoft came out on top, it has to be approved and then published by VMware. That's not going to happen. So we have to think about ways that we can start to demonstrate our performance just out there in general on Hyper-V. So that's why we work with partners like ESG, our enterprise strategy group, who've published reports now for running SharePoint 2013, just going to be published very shortly, SQL 2012, and Exchange 2013 on Hyper-V. So you can show and see how well it performs. We can't do a direct comparison today. You can, but you can't publish the results unless you send them to VMware, unless you go under the radar, which I can't do, unfortunately. But let's look at security and multi-tenancy. What is the enabler of this? At a deep level within vSphere, when you're carving up your infrastructure, networking is a big consideration. And you'll be used to creating port groups, vSwitches, and more recently, in more recent releases, the distributed switches. Hyper-V in 2008 R2's network switch was relatively simple. It provided the core functionality of what a VMware vSwitch would provide, in the sense that it would let virtual machines talk out to the external network. But it didn't have certainly any extensibility, which we'll touch on now, and it didn't have any distributed configuration mechanism, like we do now in 2012 and with System Center. So there was a couple of key areas that certainly if you were deploying and managing at scale, Hyper-V's network switch was perhaps a little bit simple. But it did the job. It was performant, but it just didn't have the extensibility and granular configuration. But that's all changed. So now when you create Hyper-V virtual switches and you bind them to a physical network adapter or a team, you are effectively deploying a Hyper-V extensible switch. And that is a big difference from a vSphere vSwitch. The vSphere vSwitch is not an extensible switch. It's how it is. It's the vSwitch that VMware defines. It's not extensible. People say, well, it's extensible because the distributed switch, the distributed switch replaces. And if you want to use the Cisco Nexus 1000V, that replaces. If you want to use the IBM equivalent of the Nexus 1000V, it replaces. So it's not extensible, it's a replacement. The Hyper-V extensible switch in 2012 is completely extensible. So partners can plug in at different layers, and we'll explore some of those in a second, that help you to provide specific functionality that perhaps isn't in the box in Hyper-V. But what is in the box? What capabilities are in there to help you provide more security? Well, things like protection against ARP and neighbor discovery poisoning, protecting against rogue DHCP servers and routers inside virtual machines that people might set up, virtual port ACLing to control what VMs can communicate with other VMs at a fairly granular level, trunking traffic to individual VNICs within virtual machines, traffic monitoring and mirroring, PVLANs for granularity within individual VLANs. All of that is built into the standard Hyper-V extensible network switch, and that's just part of Hyper-V. When we look at what people are doing around extending the platform, whether they're deploying capture extensions, whether they're forwarding, whether they're filtering, they can plug in at various layers of this extensible switch. And so that means you can combine them. So if I wanted to use Inmon's S-Flow monitoring extension, plug it into the Hyper-V switch. And at the same time, I've got Five9 Security Manager, which provides agentless antivirus and virtual firewall. I can do that at the same time. But we have got the option still to utilize the Cisco and the NEC switches. So the Cisco Nexus 1000V that was recently released. You can get hold of that if you've got a Cisco investment within your environment. So it differs considerably from that VMware approach, certainly on that extensibility perspective. But you can still achieve some of those granular Hyper-V inbox capabilities with VMware technology. It's just you either have to get the Cisco Nexus 1000V or the IBM equivalent, or you have to buy the vCloud networking and security SKU and bolt it on the top. And that's a per VM cost, but it would provide some of those capabilities that are offered in the box with Hyper-V. But how do we drive that best performance? Can we guarantee and deliver a better level of performance, networking-wise, than what we can on vSphere? Well, how do they compare and contrast? Well, Dynamic VMQ helps us process network traffic on the host level within respect to the VMs in a more optimized way. But with VMware, it's only VMQ. So the processing of that traffic can get pegged to fewer NICs. It's not as aware of fewer processors, sorry. Whereas Hyper-V with Dynamic VMQ, the processing of that network traffic is going to be handled more broadly across a wider set of CPUs and cores, which means better utilization of that system. If you're using IPsec, which Microsoft uses extensively, VMware has no capability to provide IPsec offload, which is shipping in physical network adapters today, where we can say, OK, I've got loads of VMs on host number 1 that are using IPsec to secure traffic. There's an encryption and decryption process associated with IPsec that requires CPU time. Do I want to use my valuable CPU time of my host to handle that, or can I offload it to the NIC? It's better to offload it to the NIC, and that's what Hyper-V supports. Receive-side scaling, RSS. It's been on the host for a while, now inside the guest. VMware also provide VRSS, which is a capability that inside the guest balances the processing of traffic across vCPUs, as well as RSS, which is doing it on the physical CPUs on the host. VMware, you'll need a specific network adapter inside your guests, and we'll touch on that shortly. But here's a big one. We introduced SRIOV in 2012 as a way of presenting a physical representation of a network adapter through to a VM for higher performance, higher bandwidth, lower latency, lower CPU utilization. VMware did the same in 5.1. So essentially, SRIOV, or single root I/O virtualization, is instead of me using the network path that's in the virtual machine synthetic stack, the software stack that's natively provided by Hyper-V, I take advantage of these virtual functions within the physical NIC that's SRIOV capable, and I pass one of those virtual functions into the guest, and the traffic flows down that more native path. VMware do it, Microsoft do it. With Hyper-V, it's in every SKU. With VMware, you have to have the higher-end editions for SRIOV. But that's not the key point. The key point here is single-root I/O virtualization is effectively connecting that VM more directly to the physical NIC in that host. So you think, OK, you've given me performance there. Great. Can I move that VM around still? Can I live migrate it from host to host? Because it's connected to that physical NIC there. How can I move it? Well, with Hyper-V, we fully support live migration with SRIOV. So I can simply reverse the process, fail over the traffic back to the synthetic NIC, and then move the virtual machine across to a target host. And when it gets there, if the target host has an SRIOV-capable NIC, we'll utilize it again and fail the traffic over to that path. But if it doesn't, we'll just stick with the regular synthetic NIC. So you've got complete flexibility to move VMs around with or without SRIOV. But with VMware, you turn on SRIOV for that NIC, performance is great, that VM's staying on that host. It isn't moving anywhere. So you lose that agility. So we're really delivering both with Hyper-V, but with VMware, it's staying on that host, because it's an implementation of effectively that direct path I/O, which presents PCI devices through to virtual machines, but makes them stick on that particular host. If you've got a requirement in your environment for protection, for BitLocker, a lot of people think that encryption and BitLocker as an encryption capability is on the client, it's on your laptop. Because your laptop, you leave it in airports, you leave it in taxis, the data's more important. Well, actually, a lot of organizations have servers in less physically secure locations. So we want to ensure that if you have got physical servers in less physically secure locations and you have a compliancy need to encrypt, we provide it in the box. And that doesn't matter whether your virtual disks are residing on DAS in that particular server, rack, or tower, whether they're on a traditional LUN presented from the SAN through to that host, that's fine, we'll encrypt that as well. Whether they're on a cluster shared volume, our VMFS equivalent in 2012 and 2012 R2, or whether they're on a file server, an SMB share, it doesn't matter. Wherever you're going to locate those VHD files, we can encrypt that to ensure that if you've got a compliancy demand, we can meet that with BitLocker. Do you get something for nothing? Is there a performance overhead? Inevitably, a minimal performance overhead, a couple of percentage points. But it's going to give you that compliancy at the host level to protect those virtual disks that are stored on those now protected storage repositories. So to wrap up, I was saying before, for VMware to support virtual receive side scaling, it needs to be running the VMX Net 3 adapter, because there's a choice you get. But the key one there is that SRIOV and that encryption. SRIOV with live migration, we don't want to give with one hand and take with the other. So yes, you can turn it on both, but it's only Hyper-V that allows you to still live migrate stuff around with SRIOV enabled. And then that encryption is there as well if you do have that requirement to encrypt those less physically secure servers in different locations. Let me think about flexibility. A lot of people who think about flexibility in a virtualized environment think about moving stuff around. But time and time again, I read documentation that's produced from typically VMware that talks about guest OS support. VMware will support 80 guest operating systems on vSphere. Microsoft will support 25 or something on that number, the majority of them being Windows. Support is a fine line. Using that term support, can I ring VMware and with a problem with my Windows 95 operating system inside a VMware virtual machine? Because it's claimed to be supported on VMware. It's one of those 80 operating systems. But the reality is it's no longer supported by anybody who makes it. A lot of the Linux distributions are the same. We work with the Linux community and the commercial Linux vendors to help drive increased performance and compatibility inside Linux and Hyper-V, and we work on them from a supportability perspective as well. So Hyper-V today supports CentOS, Red Hat, SUSE, OpenSUSE, Ubuntu. But that's not to say that all of the other distributions won't run and run really well. Because we've ensured and we've built our drivers for Linux, working with that community. We've worked with them so closely that our drivers are now in the core kernel, further up the tree, so any distributions that come from that have the drivers built in. And they don't appear as non-standard drivers. They're part of the core kernel. They're accepted. They're optimized. And it wasn't just about getting that compatibility from a driver's perspective. It's then about lighting up the features. So when we go forward to 2012 R2, we're delivering Resizing of virtual disks, just like for Windows VMs. Full dynamic memory support, which is coming in R2 for Linux VMs, just like Windows VMs. So we're trying to provide all of the capability you get for Windows environments inside the VMs, or as many as we can inside the Linux environment. So don't be afraid if you've got a Linux environment or a Linux set of virtual machines or a Linux physical infrastructure you're thinking of virtualizing, Hyper-V is a great solution for that. However, what if I'm running a load of free Linux distributions in production in my environment? Would I want to go and buy Windows Server 2012 or 2012 R2 Hyper-V just to run a free distribution? Or in the same light, would I want to go and buy a vSphere infrastructure just to run a free Linux distribution? And you might not want to. So that's where Hyper-V Server is a great fit, because it's got all of the Hyper-V capabilities, but it can still run those Linux guests just the same way that Windows Server with Hyper-V would, and yet it's free. And you wouldn't need to pay the operating system rights nor the hypervisor rights. But you could still have HA, live migration, all the cool features that Hyper-V provides. So it's worth bearing in mind. With vSphere, you could go out and download ESXi, but the scalability is capped, doesn't have any resiliency, nor any vMotion type capability. You have to go for vSphere for that. So something to be aware of. Can I clone VMs in vSphere? Yes. With vCenter, I can clone virtual machines, and I'll actually do a pretty good job after the fact of customizing and generalizing that virtual machine once the cloning has taken place. With Hyper-V and with VMM, it's a little bit more clean, it's a little bit more simple in the sense that I do a live export of the running virtual machine, it copies that disk, I can live export from snapshots, I can live export from just a single virtual disk, whichever the current configuration is. So I could have a snapshot chain, and I'm not promoting snapshots in production, just before anyone goes down that route, because I think we've all been burned by that. But I can have a snapshot chain perhaps for a dev or a test environment, and that snapshot chain, I may want to create a brand new whole VM from the fourth snapshot in the chain. Okay, right-click, export, out it goes. And I've got a full VM that's not loads of snapshots together. It's a full merged VM that I can take and give to my dev team and start testing from that snapshot point in time. But this is in 2012 R2. So I can't do this live in 2012. So VMware still has an advantage at that front at this point in time. And once that virtual machine's exported, we can start it up and bring it in. But it is identical, literally identical. So you're going to want to think about IP address, DNS name, that kind of stuff when you bring it online. Or bring it online in isolation. I think by default, it won't have the network connected post-export. Now, as VMM, if I'm using VMM with Hyper-V, then I've got a bit more of a granular process, kind of like what you'd see with vCenter. But then we get onto mobility. VMware did a fantastic job, 3.5, probably even earlier, introducing vMotion to the world. And it was kind of a mind-blowing moment for a lot of IT admins. It's kind of, wow, you've actually just moved a server from there to there and nothing went wrong and nothing happened, no downtime. Yeah. And it was a fundamental, fantastic innovation. And now time has moved on, and it's in Citrix Zen Server, it's in Hyper-V, and a lot of organizations offering it for free. We've seen that feature drop down the vSphere SKUs to the SKUs that are now more applicable to even SMBs who are virtualizing just a handful of servers. They can take advantage of the vMotion technology. And in Hyper-V in 2012, we wanted to make sure that we enhanced live migration to a point where we were enabling lots of live migrations simultaneously, concurrently. So that was a big improvement. And now in 2012 R2 going forward, we're really taking strides ahead to improve live migration still further and go beyond what vMotion is doing. By introducing compression, squeezing that virtual machine memory before we ship it across the wire. So utilizing free cycles that are available on the hosts to compress the memory and then send it. We can see twice the live migration speed through doing that, which means we get the virtual machines across there quicker, we evacuate hosts more quickly, we free them up for maintenance maybe more quickly. And quicker still, so if I'm using 10 gig Ethernet or less for my live migration networks, compression's the way to go. But if I'm using more, if I've got more pipes, and if I'm using perhaps RDMA-enabled network adapters, we can send that traffic across the network even faster and reduce the time for a live migration down an incredible amount. An incredible amount, more than double what compression would provide. So again, if you're thinking, well, I'm going to provide multiple NICs for my vMotions, would I do the same thing for Hyper-V? Yeah. And with Hyper-V, live migration, and the RDMA support and compression that's coming in 2012 R2, it's going to accelerate live migration considerably. But we were catching up in other areas before 2012, because VMware had a storage vMotion for quite some time. And it enabled administrators to flexibly move stuff around their SAN, or at least their storage infrastructure, perform maintenance, that kind of stuff, or even move from a capacity perspective. That's really useful. And now it's been enhanced to the point on the VMware side that with storage DRS, it's using the storage vMotion technology to move virtual disks around the storage array based on capacity needs, IOPS, whatever it may be. So whilst Hyper-V in 2012 introduced live storage migration, so we can manually move the virtual disk from A to B to C, we don't have that storage DRS capability, which is looking at the infrastructure and moving virtual disks around automatically. Could it be done? Absolutely. Do we have monitoring tools to monitor? Yeah, Ops Manager. Do we have automation tools to automate a runbook to trigger a virtual disk move? Yeah, Orchestrator. Do we have a tool to move the virtual disk? Yeah, VMM. So within System Center, we could fashion something, a runbook that's automated, that's based on the changing conditions of our environment. We could do it. It's just not a feature that we say, there you go, out of the box, tick here, which maybe that will come in the future, who knows. And then finally, as I said before, we want to remove those shackles. We want to help you move workloads around flexibly anywhere. And this was a first in the industry in 2012. The ability to pick up a VM, and when I say pick up the VM, I mean its config file, its running state, its virtual disks, everything about that VM, and then just throw it somewhere else. Push it to that host over there. Cluster, standalone host, doesn't matter. Local storage, SMB storage, SAN storage, doesn't matter. As long as we can connect to it via a network cable, I can move that virtual machine with shared nothing live migration. And going forward in R2, that will be enhanced. Certainly the memory state of the VM element of that migration will be enhanced by compression or RDMA. Now, VMware responded in 5.1 with a similar capability. However, those of you who aren't using the vSphere web client, so if you're still using vCenter client, the rich client that you would run from the desktop, you'll still see that option grayed out. Can I change data store and vMotion at the same time? That option is grayed out. Go to the web client, and then you can do it. Okay, so it may need, if you want to utilize that functionality in vSphere 5.1 specifically, you'll have to go to the web client to do that. But something that people were crying out for, and to be honest, hats off again to VMware, because this has been in vSphere for ages. That ability to move virtual workloads off physical hosts, upgrade them, and then vMotion to the newer host. It's given you a lot of flexibility to streamline vSphere upgrades, and it's kind of been a bit of a jealousy thing. I'd love to be able to do that, because whenever 2008 came out, customers would get excited. How do I get from 2008 to 2008 R2? Well, there's going to be a bit of downtime. What about 2008 to 2012? Well, there's going to be a little bit of downtime. We're going to shut that VM down. We're going to move the files, bring it back up. The VMs will still work fine, but there's going to be a little bit of downtime. 2012 to 2012 R2, there's no disruption. And that little image, that little diagram there, as it was showing, if we've only got 3 nodes in our simple example, we'll rebuild one of the new nodes, we'll upgrade it to 2012 R2. Probably best to do a complete rebuild rather than in place, but that's up to you. We'll do the same on the next one, moving VMs from 2012 to 2012 R2. So it's in the box, it's part of the core operating system, automate it with PowerShell, simple, flexible, and it's a step in the right direction. But it very much is something that VMware have had for a long, long time, and fair play to them. It's something that really enables customers to move quickly. And that's why in a lot of the customer engagements unless they're massively complex, huge environments, we found that customers would move from version to version very quickly after release, because they could move flexibly using the inbox tools. But when we come to flexibility as well, we have to think about networking. When we think about networking in the regular sense, like we talked before, we talked about vSwitches, we talked briefly about distributed switches. Hyper-V on its own does not have a distributed network switch. VMM, Virtual Machine Manager, provides that distributed switch for Hyper-V. Okay, something to be aware of. But then when we think about how we change the way we deliver networks, Microsoft is really pushing, through System Center and Windows Server, a different way of pushing out the network, of configuring and deploying networks, moving away from needing VLANs, but still having segregated traffic, segregated workloads, having flexibility to move virtual workloads beyond subnets. We can do that now with network virtualization. But there's a couple of things, a couple of terms and bits you need to understand about how this works. At the physical layer, we've got these things known as provider addresses. These are uniquely routable IP addresses on the network, on the physical network. And on top of that, we create our virtual networks, our VM networks. So we've got red and we've got blue in this example. These networks are what could represent groups within our enterprise or customers within a service provider. But you'll notice that they've all got an IP address individually, those VMs. Those individual IP addresses are what are known as customer addresses. And we need to maintain and understand just where virtual machines of customer address 10.10.10.10 of the blue network resides in the infrastructure. And VMM handles that. So Virtual Machine Manager maintains the brain, the policy table, and the relationship between where the VM is, what VM network it's part of, and what provider address that VM is currently running on. So if we ever need to find a VM, for instance, and ping it, which we'll look at in a minute, I know that 10.10.10.10 customer VM is running on the 192.168.2.10 physical host. So it maintains those relationships and handles the encapsulation and decapsulation around that. And the reason those two are starred there is that if you think about those two VMs there on the blue and the red network, the customer addresses are identical. 10.10.10.12 for blue, 10.10.10.12 for red. They're running on the same physical host, the same provider IP. Does that matter? No, because network virtualization is isolated blue and it's isolated red without the need to use VLANs. So we're providing that flexibility to deploy virtual networks easily. We saw it in the foundation session. If you've gone to any sessions or labs, you'll now start to realize how easy it is to start to deploy network virtualization. And we're really trying to make it acceptable and easy to deploy for a lot of organizations. And as I said, it means we can route traffic across different subnets. We could migrate virtual machines across subnets. But how do VMs communicate? How does VM on the left, 10.10.10.10, communicate with another blue VM on the right, 10.10.10.11, even though they're on separate physical subnets in the infrastructure? Well, as long as those physical subnets are routable, as long as physical host on the left can communicate with physical host on the right, then we can assemble the packet. So the VM, what the VM sends out on the right, with the source and destination MAC, encapsulated with some physical information for it to get from A to B. And I want to walk you through that just briefly to explain how this works. Because VMware do things differently with VXLAN. It's not to say that one is right and one is wrong, but we feel that what we're delivering in network virtualization is less complex, it's scalable, it goes well beyond 16 million networks as opposed to 4,095 VLANs. It's hugely scalable. But how do things talk? Well, if I want blue 1 to talk to blue 2, what's going to happen? Well, naturally, in a regular guest OS, it has no idea that it's part of this virtualized network. So it's going to send out an ARP and says, hello, where's 10.10.10.11? It's going to fire that out of its network adapter, and that's going to go naturally into the Hyper-V switch. The Hyper-V switch is going to look across its VM network and see if the VM that it's looking for is currently located on the same Hyper-V host, because that's going to save a lot of time, a lot of effort. So it broadcasts that ARP on the local virtual subnet ID, the VSID, so the blue network, essentially. So it broadcasts that out, and if nothing comes back, the Hyper-V switch then broadcasts that ARP on from its vSwitch into what's still within the vSwitch, but the network virtualization layer catches it. It says, right, I know what you're trying to do here. I'm going to start to construct the right packet to communicate out to the network. But before it does that, it checks its policy table with VMM and says, do you know where 10.10.10.11 is? Okay, yeah, you do. Thanks. Give me that information. It might already have the information, but if not, it will get it from VMM. And it will send that relevant information to the guest OS to tell it where it is. The guest OS will then construct its packet, source and destination MAC, source and destination IP, just like it would in the physical network world, sends it into the switch attaches the appropriate vSID, so when it gets to the other host knows which VM network this is part of, blue or red. In this case, it knows it's blue, checks whether it can communicate, and it's at that point that the magic happens. Not in the animation on the slide, but more so in network virtualization. Because now we encapsulate that whole VM packet. And remember, the VM is completely unaware of all of this. We encapsulate that whole packet essentially in a GRE packet. And the contents of that GRE bit are How do I get across the physical network to send this VM packet onwards? So it gets there through the source and destination physical MAC and the source and destination physical IP, which is kind of on the end. One way to think about it is if you were sending a letter. You write your letter, that's your packet. You want to put it in the mail to send it, but if you just put it in the mailbox, it wouldn't get there. You have to wrapper it in the letter, and you put the physical address of where you want to send it to on there. And when it gets received at the other end, they open it up and they get the packet. It's that kind of approach. We're just using it as a transport. So that packet gets there and it's de-encapsulated at the other side. But we want to make sure that we can also provide a solution in the box to enable you to communicate between VM networks and the outside world, physical devices, service provider networks. And to do that, because these VM networks are encapsulated, they're isolated, we need to figure out how we can do that. And that's where the gateway comes in. A multi-tenanted, site-to-site VPN gateway for that very purpose, to connect different infrastructures or to connect your data center, which is using network virtualization, with your desktops, which aren't. You need that bridge and that gap, and to bridge that gap, and that's where the gateway comes in. Now, if we start to look at what VMware are doing in this space, live migration, yeah, across the board, VMware pioneered the technology back in one of the previous, in virtual infrastructure, ages ago. But with compression and RDMA, which is coming in 2012 R2, we're really pushing forward with new innovation in this area to help you be able to live migrate faster. If faster isn't an issue, if you just think, I'd just like to be able to live migrate for free, well, it's in there, Hyper-V, it's in there, it's no charge, it's part of the OS. When we think about some of the other features within vSphere, many of you will no doubt use DRS, Distributed Resource Scheduling, which will balance virtual machines around your vSphere cluster automatically based on changing conditions. Hyper-V on its own won't do that. It's got the live migration engine to shift stuff, but it's not got the brain to know exactly where to move stuff optimally based on the whole environment. And that's where VMM, Virtual Machine Manager, provides dynamic optimization on the top. And in addition, power optimization. So if you had a big cluster and you thought, you know what, every weekend there's no real load across our VMs, could we run those VMs on fewer nodes of the cluster and power down the ones here? And if there is a spike in load, wake them up. But if there's no spike, just wake them up on Monday morning. Yeah, VMM can do all of that. So the distributed power management within vSphere, DPM, there's an equivalent in Virtual Machine Manager. So if there are key features you use in your environment and you're thinking, is that in Hyper-V? Yeah, it is. But it's provided by System Center. Hyper-V is just that engine. And we touched on live storage migration and shared nothing as well. As I said before, VMware's got a slight improvement on the old live virtual machine cloning and some of the customization they can apply. And we're still catching up on that live migration upgrade side of things to ensure that we can help you seamlessly move to 2012 R2 from 2012. If you're not on 2012 and you're thinking, well, I'm on 2008 R2 or I'm on a different, can I get there to 2012 R2 with no downtime? No, it will be from 2012 to 2012 R2. If you want to do network virtualization, and you'll hear a lot about it this week. By the end of the week, you'll have it coming out of your ears. But it's a big, big deal. And we're providing it in the box. With VMware, with VXLAN, if you want to use VXLAN, you're going to have to use the vCloud Network and Security SKU, which is an extra, for both the VXLAN capability itself and the edge gateway to allow it to communicate with physical devices or outside world. Alternatively, you could buy the vCloud suite, which would include all of that. But where does Nicira sit? Because VMware paid $1.2 billion for a network virtualization technology. If I'm a VMware customer and I'm thinking I'm going to go down the VXLAN route, and to deploy a VXLAN infrastructure, it's a big deal, just like deploying a network virtualized infrastructure on Hyper-V. It's a fundamental fabric of your data center. It's not something you do today and then rip out tomorrow. So if I'm going to deploy VXLAN and then Nicira comes in, what does that mean for me? How much change is involved in that? That's something I'd be looking to understand. Network virtualization is only going in that direction from Hyper-V and with System Center. So to wrap up, HA. Within a lot of this vSphere documentation, we get a little bit of a bad press around not providing a resilient solution for virtual machines. Clustering is the foundation, Windows Server clustering is the foundation for Hyper-V resiliency. But a lot of people base their clustering experience now and their perception on clustering from the 2003, maybe 2000 timeframe. And it is radically different in 2008, R2, and then 2012. Clustering is simple to configure. It's supported on general hardware, so as long as your hardware is on the Windows Server catalog and you've run validate to ensure that it's checked it for all the errors that could potentially be there, run valid. Right? Yes. Validation of a 64-node cluster in 20. Have you run it on 2012 R2? 2012? Yes. So it takes a while to run in a big cluster with a lot of storage. That's a great point. A great point. Validation is going to try and break that cluster. So the question was, how is that efficient? Running a cluster validation on a 64-node cluster with a lot of disks, because all of the disks are failing over across all of the nodes, it's going to take a long time. Without disks. That doesn't sound right to me. So I'd like to... Right, I'd like to talk to you more about that. Yeah, if that's the case, then that's not efficient. Okay, but that validation, irrespective of the time it takes, the aim it's trying to provide is to make sure that when you do build on top of that cluster, that it's a solid foundation. So yeah, I'd love to catch up with you after the session as well to talk more. But what's it trying to do? When we build that cluster, there's a number of votes that are associated with each node. So each node has a vote, the storage has a vote, and that's how we maintain quorum, the consistent state of the cluster. Now, if I were to lose a node, in 2012 R2 and 2012, we introduced something called dynamic quorum. So that if I were to lose a node, the quorum automatically adjusts itself to reflect the new number of nodes in the cluster. So we could lose a significant number of nodes in one hit, a whole rack, for instance, and the cluster will stay up and running. Okay? So that's providing that foundation. But when we start to build on top and we start to think about how we can cluster at the guest level, that's becoming more and more important. Guest clustering with things like SQL clusters, SQL availability groups in 2012, Exchange DAGs, SharePoint farms. Those kind of guest clusters, we may want to do some clever things around ensuring that we can not only cluster at the guest level, but keep VMs apart. Affinity, priority for when things reboot as well. So guest clustering is not only simple to configure and fully supported in 2012 and R2, and if we were to lose a physical node, that guest cluster node would restart on another physical server, and if that node comes back online, we can then still live migrate and utilize dynamic memory for those virtual machines. So we're not restricting based on that particular guest cluster configuration. But in 2012 R2, that guest clustering is no longer tied to the underlying physical topology. So we now support something called shared VHDX, where I can create a guest cluster, I can attach a single virtual disk to both nodes or up to 64 nodes in a virtual guest cluster and store that on the storage topology of my choice. So it's just about flexibility. Can I create guest clusters with vSphere? Absolutely. Yes, I can create them. But some of the configuration choices you have are a little bit more restricted. For instance, I can't vMotion guest cluster nodes around the physical infrastructure. And I can't use memory over commit. It would probably work, but it's not officially supported. So something to be aware of. And VMware actually has done a really good job with their vSphere hosts of enabling you to keep VMs apart within your environment. Because if you had a cluster, for instance, a guest cluster that you wanted to keep apart, maybe it's 2 Exchange nodes of an Exchange DAG. If you want to do that, then setting that affinity, or that anti-affinity in this case, is very, very useful in a vSphere environment. And it was something that was introduced. It could be done in 2008 R2 Hyper-V. It was streamlined in 2012, and it's made easier when you manage it through VMM. So creating what's known as an availability set automatically keeps virtual machines apart that you want to keep apart. Imagine you had a web farm, for instance. You would never want that whole web farm to be on one physical host. You'd always want to keep them apart for best practice. So both Hyper-V, both vSphere have strong HA capabilities built in the box. Prioritization's there from Hyper-V. A little bit more granular on the vSphere side. But the affinity rules, NIC teaming for NIC resiliency is now in-box in Hyper-V. That was a common piece of feedback, shall we say, from 2008 R2. I'd like a NIC teaming solution like vSphere that's just in the box, so I know where I need to go if I've got a problem with support. I don't want to have to install third-party tools for something as fundamental as NIC teaming. And that's the feedback we got, and we listened and we built it into 2012. So it's NIC teaming in the box. And that's been improved in 2008 R2 with a new dynamic load balancing mechanism to help increase performance. But when we think about the size, Scalability of Hyper-V clusters is that little bit bigger, but again, does it matter? For some customers, yes. The examples I talked about before with the 64-node cluster, big environment. But a lot of organizations, even with 32-node vSphere clusters, a lot of the customers I talked to were 12, maybe 14, 15 nodes, but they had multiples rather than go for a big 32-node. And that may be the same with customers on Hyper-V. The size is big enough for most organizations. But a key thing with the live migration, if you are clustering at the guest level, you can use live migration and be supported with Hyper-V, clustering, live migrating those guest cluster nodes, and using dynamic memory if it's appropriate for that workload. But it's not just about local failure. If a host fails, failover clustering is going to ensure that VMs automatically restart, kind of like VMware HA would. But we want to also provide a solution that if you, for instance, have multiple sites or you're working with a partner or service provider, that you can protect VMs at an even greater distant level. So, for instance, I may want to configure these VMs and replicate them to a second site. And with Hyper-V Replica, which is in-box in Hyper-V, doesn't require a virtual appliance, right-click VM, enable replication, and off it goes. Now, it is a VM by VM configuration, or I could do it through PowerShell, or do it through some of the Azure solutions we've got in market now that we talked about in the keynote. But that effectively replicates the VMs from A to B. Doesn't care whether it's on block storage going to DAS, DAS storage going to SMB, SMB going back to SAN. The replication is agnostic of the hardware and the storage. So it's giving you a great flexible VM replication in box. Now in 2012, it's every 5 minutes, the replication. In 2012 R2, it's every 30 seconds, or every 5 minutes, or every 15 minutes. It's configurable. That was a big improvement in 2012 R2 to give you that granular control, which is important. Once you've replicated the initial replica, it's just doing the delta changes every 5 minutes in 2012. But what if you lose a main site? If you lose the whole site, well, on the second site, you can bring that up within, you could have just lost 5 minutes of data max. Or if you've got lower latencies and the rate of change in your environment is high, then there may be slightly larger data loss. But you would have event log messages that would help you monitor and track that. Now, what happens if we want to go beyond that second site? Well, in 2012 R2 specifically, we're extending replication still further. So we've got primary to secondary sorted, but I'm a service provider, I'm working with you, you've replicated to me, I'm looking after your environment. But I need a resilient infrastructure myself. Yeah, my main site's resilient, but I need a second site as well. So I can now replicate your stuff to a third site as well. So you're replicating to me, I'm replicating that same stuff onto a third site for extra levels of resiliency. That's in R2. Okay, so that's something new that we introduced in 2012 R2. So if we start to compare some of the replication, it's in the box in vSphere, it's in the box in Hyper-V. vSphere replication and Hyper-V replication, both available for customers at no charge. They're in the box, but there's some subtle differences between Hyper-V replica and vSphere. Even if you take out the R2 elements of this, so the changes around the configuration of replication time, and just focus on the 5 minutes. Hyper-V replica is every 5 minutes, vSphere replication every 15. It's in box with the hypervisor versus having a separate virtual appliance to manage. But some of the key things around, can I do a planned failover? I.e., I've got a phone call, my infrastructure needs to be shut down now and moved, I can do that with Hyper-V replica. I can test failover. I can configure the IP addresses in advance of failing over. So when they come up on the second site, they've got the right IP address for that environment. All of those granular features are in box with Hyper-V replica, but they're extra. They would be needed with SRM from VMware, so you need to bolt that on the top. So something to be aware of. But Hyper-V replica is only software-based replication. So if you've got storage replication, this isn't going to take advantage of it. Whereas with SRM on the VMware side, it can hook into your existing storage array as well, which is great. But if you do want to orchestrate and you're thinking about low-cost solution, I could use PowerShell to orchestrate replica. I could use Hyper-V Recovery Manager, which is that Azure service, to replicate. But there may be a charge of that. We've not announced pricing at this time, so I don't know. With SRM, that's the only way to automate vSphere replication. So to wrap up, we've looked at scale, performance, we've looked at security and multi-tenancy, we've looked at flexibility, and we've looked at HA, and there's loads more stuff we could have talked about. You know, we could have gone lots of different ways. There's tons more stuff, but hopefully this has given you a good overview of just some of the key capabilities, some of the things to be aware of on both sides. And with that, I'll wrap up. Thank you very much for your time and enjoy the rest of your day.